Hello, welcome to Grafana LGTM Stack course. My name is Mohammed and I'm very happy to be here. In the previous section, we covered all required topics of Grafana Loki, and it's now time to work with Grafana Mimir, another amazing tool of Grafana Stack. In this section, I'm going to explain the architecture of Mimir as well as setting up and installing Mimir within our Kubernetes environment. And in the next section, I'm going to show you how Grafana Mimir works, okay? So the most important question is that what is the difference between Prometheus and Grafana Mimir? And the next question is that is Grafana Mimir a replacement for Prometheus or not? Actually, Prometheus is a monitoring solution, is a single application which discovers many different applications and machines on the network. And this is a pool-based model. It means that it scripts metrics from different targets. And it has a built-in time series database and it works well. But Grafana Mimir is a time series database and it acts as a long-term storage for Prometheus. And it's very important to know that Grafana Mimir is not a replacement for Prometheus, but you can add Grafana Mimir to your existing monitoring solution, and it can be the backend storage for your Prometheus instance within your monitoring architecture if you have Prometheus. Okay? Grafana Mimir has a set of features such as high availability, horizontal scalability, and also multi-tenancy. About high availability, Grafana Mimir has a built-in feature called zone-aware replication, which means that you can deploy and install Grafana Mimir within different racks, different data centers, and different zones to ensure high availability to avoid any data loss. Okay, so it's important. And another feature of Grafana Mimir is multi-tenancy, to isolate metrics from each other. It's so important. Let's imagine that we have two different teams within our organization who are working on different applications. For example, team 1 is working on application 1 and team 2 is working on application 2. I prefer team 1 to be able to query to the metrics of their own application only. And I prefer team 2 to be able to query to the metrics of their own application as well. So in this situation, multi-tenancy comes into the play and it plays a crucial role to isolate metrics from each other, isolate metrics by teams, okay? So in this course, I'm gonna show you how multi-tenancy in Mimir works. It's very, very interesting, okay? So these are the features of Grafana Mimir and these are the reasons for you to add Grafana Mimir to your existing monitoring solution. I scroll down here to explain the architecture of Grafana Mimir. In this picture, we have Mimir in the middle of this picture. And in the left side, we have many different tools such as Prometheus, Grafana Agent, and OpenMetrics. In this course, and for Grafana Loki section, we learned how to work with Grafana Agent, and you should be familiar with Grafana Agent right now, okay? And one of the features of Grafana Agent as well as Prometheus is Remote Write API. It means that you can script metrics from different targets in Grafana Agent or Prometheus, it doesn't matter. And then you can write your metrics from Grafana Agent or from Prometheus remotely to Grafana Mimir. Okay? And then you can connect Grafana to Grafana Mimir as a data source. Because Grafana Mimir can be added to Grafana's instance as a data source. And then you can query to Mimir instead of Prometheus. Because Mimir can act as the backend storage for your Prometheus if you have, okay? Or, for example, you can replace Grafana Agent with Prometheus. It means that you can script metrics from different targets using Grafana Agent and then write the metrics from Grafana agent remotely to Grafana Mimir. Okay, so Grafana agent can be an alternative to Prometheus because it's able to script metrics from different targets. Okay, but let's dive deeper into the architecture of Grafana Mimir here. Grafana Mimir has many different components, and these components are divided into write path as well as read path. The components of write path are responsible for writing operations, and the components of read path are responsible for read operations. Okay? Let's start with write path. The first component of write path is distributor, and the next component is ingester. Ingester receives samples from distributor, and these samples are both kept in memory and written to write-ahead log. Write-ahead log is so important to recover your in-memory samples. For example, let's imagine that your Grafana Mimir's instance interrupts and your in-memory samples will be destroyed. Okay? In this situation, write-ahead log helps you a lot to recover your in-memory samples. Okay? The next responsibility of ingester is creating time series database blocks. Okay? It creates TSDB blocks from these samples, and then ingester will upload these TSDB blocks to an object storage. So you need to connect an object storage to your Mimir's instance. And this object storage can be, for example, an AWS S3 bucket, a Minayo bucket, a Cloud Azure storage, Google Cloud storage, and so on. Okay, so you need an object storage, and this object storage receives TSDB blocks from ingester. Okay. The next component here is compactor. Compactor connects to object storage and merge multiple TSDB blocks into single block. Okay, and also removing duplicated samples. It's important. This is an important component within this path. I mean, write path. The next path is read path, and these are the components related to read path. When you perform a query against Grafana Mimir, query frontend is the first component is going to be involved. Query frontend receives your query and then split this query into multiple queries, into smaller queries, okay? And then checks its result cache. If the result of the query has been cached, the result will be returned to the user. And if not, the query will be stored in a queue. And this queue is maintained by query frontend or query scheduler. The next component is querier. Querier acts as a worker and it pulls queries from this queue. Okay? And it tries to execute these queries. Because of that, it's going to connect to ingester as well as store gateway to fetch the result of the query. And then the result of the query will be returned to query frontend and finally to the user. So querier needs to connect to ingester and the store gateway to fetch the result of the query. Okay, so this is read path. If you're going to deploy Grafana Mimir within your environment, so in this course, I'm going to install and set up Grafana Mimir within our Kubernetes environment. You have different ways of deploying Mimir. The first way is monolithic mode. Monolithic mode means that we have a single binary application. This is a single binary application. and all required components of Grafana Mimir will be stored in a single application. Okay? In this situation, you can just scale this single application. You are not able to scale these components separately. Because of that, I highly recommend you to not use monolithic mode for production environments. But if you want to get started with Grafana Mimir and try to work with in test environments, monolithic mode can be a suitable choice for you. Okay? But the recommended way to use for production environment is Mimir distributed or microservices mode. In microservices mode, these components, distributor, ingester, querier, query frontend, store gateway, ruler, and compactor, all of them are going to be deployed separately within your, for example, Kubernetes environment. And after that, you can scale these components separately. For example, let's imagine that we have high load and high traffic on a specific component or on a specific path. For example, in a specific time, we have a higher load, a higher traffic on read path or write path. We can scale the components of this path separately. So scaling the application is more flexible using microservice mode or Mimir distributed. Okay? So in this course, I'm going to set up and install Mimir within our Kubernetes environment through Mimir distributed way. So let's go to do that. First of all, I go to the browser and I type Helm Mimir. The first result here is get started with Grafana Mimir using the Helm chart. I click on it. And I scroll down here, and the first step is creating a namespace for deploying Mimir, okay? So first of all, I type kubectl create ls Mimir, and the namespace created. The second step is adding the repository of Grafana. I added it already, so I don't need to add this repository once again. But if this repository does not exist within your environment, you need to perform these two commands, adding the repository and then updating your repositories here. And the next step is installing Mimir within your environment, but I highly recommend you to first check the default values of Mimir Helm chart and modify some key value pairs based on your needs, based on your environment, and finally deploy Mimir within your environment. Because, for example, you may need to integrate object storage with your Mimir cluster. You need to, for example, modify the replicas of Mimir components and so on. In these situations, you need to modify default values of Mimir Helm chart. So if you want to check the default values and then modify them based on your needs, you need to perform this command. For example, Helm show values and the name of the chart. It returns all values of this chart, but if you want to save it in a file, you can redirect it to a file. For example, Mimir values.yaml. I did that already, so I don't need once again. So when I click on my VS Code Visual Studio Code, I have a file here called Mimir original values.yaml. These are all default values, key value pairs related to Mimir Helm chart, and I need to modify some of these values here. For example, I need to integrate an object storage with my Mimir cluster. So when I type S3, for example, I need to integrate an object storage with my Mimir cluster, as well as modifying the number of replicas of my Mimir components here and so on. Okay. So in these situations, you need to modify these values. So I did that already. So when I type ls, I have a file here called Mimir values new. And this is a file that I prepared it already. And these are all key value pairs, all modified key value pairs that we have, okay? So Mimir value is new. These are all modified key value pairs, and I need to install Mimir within my Kubernetes cluster using this file. For example, I integrated my Minayo instance with Mimir cluster here, as well as modifying the number of replicas for Mimir components here, as well as setting up and configuring alert manager configuration here within Mimir instance, and also specifying the storage class for my Mimir components here, and so on. So if you want to do all of these works, you need to modify default key value pairs of Mimir here. If you probably know, I'm going to deploy Mimir within my Kubernetes cluster, but this cluster is a test environment. I don't need high availability, zone-aware replication, and so on. Because of that, I decided to decrease the number of replicas of Mimir components, such as query scheduler and querier. And the number of replicas here is 1. But the default is, I think, 2 or 3. So when I go back to my VS Code and I type, for example, query scheduler, yeah, you can see that the number of replicas for query scheduler is 2 by default, but I decreased this number from 2 to 1 because I'm using test environment. But I highly recommend you to not modify these numbers, and if you can, increase these numbers if you're running Mimir within a real production environment. Okay? But in a test environment, I decreased these numbers here. Querier and query scheduler. And this is the configuration of my alert manager. For example, I'm specifying the contact point of my alert manager. And whenever an alert rule fire, I'm going to send my alerts to a specific Mattermost channel, and this is the URL of my Mattermost channel. And the name of the receiver here is Slack notifications or Mattermost notification, whatever you want. But I'm specifying a receiver, a contact point for my alert manager related to Mimir here. Alert manager fallback config. So when I search for fallback config within this help chart, you will see that it has a default configuration, but if you want to specify your desired contact point here, you need to modify fallback config within your file here, as I did here, okay? So this is the target of my alerts. This is the contact point that I modified here. And also, the storage class name here is standard. You can also specify the name of the storage class of your Kubernetes cluster. If you have multiple storage classes within your Kubernetes cluster, you need to specify a storage class for your Mimir components to persist their data. And another feature that I disabled here is zone-aware replication. Zone-aware replication is the replication of data across failure domains, and zone-aware replication helps you to avoid data loss during a domain outage. Grafana Mimir defines failure domains as zones, and depending on the underlying infrastructure that Grafana Mimir is deployed on, zones could be, for example, availability zones, data centers, racks, and so on. Okay. Without zone-aware replication enabled, as I did here, I disabled zone-aware replication. Grafana Mimir replicates data randomly across all components replicas, regardless of whether the replicas are running within the same zone. But with zone-aware replication enabled, Grafana Mimir ensures data replication to replicas across different zones. It's so important. But so if you're running Grafana Mimir within a production environment, I highly recommend you to enable zone-aware replication. This is enabled by default, but I disable it. And also configure your zone-aware replication for store gateway as well as ingester. But we are running and we're deploying Mimir within a test environment, so I disabled zone-aware replication. So when I search for zone-aware replication here, you can see that the default value for zone-aware replication, for example, for alert manager here, is enabled false, but for ingester is true, and for store gateway is true as well. Okay, but I disabled this feature for ingester as well as store gateway. The another thing here that this Helm chart is going to deploy a Mimir, a Minayo instance for you. As I said earlier, one of the components of this architecture is an object storage because ingester needs to upload time series database blocks to an object storage. Because of that, this Helm chart is going to create a Minayo instance for you to be the object storage of your Mimir cluster. But I disable it because I have a pre-ready Minayo instance and I'm going to use that instead of using a new instance. Okay, so I disable it and it's enabled by default. So when I type for Minayo here, you can see that its default value is true, but I disable it because I have a pre-ready instance of Minayo and I'm going to use it instead of using a new instance. And also you need to create, first of all, you need to connect and integrate your existing Minayo instance or, for example, a strip bucket instance with your Mimir cluster and then specifying the name of the bucket for block storage as well as alert manager storage and ruler storage. As you know, I'm using this endpoint for my Minayo instance. So when I go to the browser and I type local Minayo-local and its port, you can see that I have a pre-ready Minayo instance and it's working well. So I log into this instance here. I have two buckets here, Loki-chunks and Loki-ruler. And I'm going to create two new buckets here. Mimir-tsdb for block storage and Mimir-ruler for alert manager storage and ruler storage. So I go to buckets here. I click on create bucket. The first bucket is Mimir-tsdb. And the second bucket here is Mimir-ruler. Okay. So when I click on object browser, you can see that I have two new buckets here, Mimir-ruler and tsdb. And also you need to define the access key and secret key of your Minayo instance. So when I go to access keys, you can see that I have many different access keys and secret keys here, and you can grab one of them and use it here. Secret access key as well as the access key ID here. And the name of the buckets you created earlier, okay? First of all, you need to create these buckets within your Minayo instance, for example. Integrate your Minayo with Mimir and then deploy Mimir within your Kubernetes environment. So I save this file and I copy this command from here. And instead of Mimir-test, I type Mimir only. And the name of the file that we modified and that we created actually to modify default values of Mimir Helm chart is Mimir values new.ym. So let's wait for deploying Mimir within Mimir namespace. Very good, Mimir has been deployed. So when I type kubectl get pod-n Mimir, you can see that these are all components related to Grafana Mimir. So I'm going to wait for these components to be up and running, and then I will continue to work with Grafana Mimir here. So when I type kubectl get pod-n Mimir once again, you can see that all components of Grafana Mimir is up and running. Very good. So we have Mimir Alert Manager that we explained earlier. Compactor is responsible to compact and merge multiple blocks into a single block, and also removing duplicated samples. And distributor is a component related to write path. Ingester, we have 3 replicas of ingesters here. This is a very important component here because it keeps in-memory samples as well as read into write-ahead log, creating TSDB blocks, uploading them to object storage. So this is a very important component here. Query frontend, query scheduler, store gateway, and so on. And also, we have a component here called Mimir-Nginx. We need a reverse proxy, actually, to proxy requests to Mimir cluster, okay? Because of that, this Helm chart prepares and configures Nginx to proxy requests to Mimir cluster. So whenever you want to connect and integrate Grafana with Grafana Mimir, you need to enter and type the URL of Mimir-Nginx. And after that, this component will be responsible to proxy requests to Mimir cluster. So this is the reverse proxy of this cluster here. Okay? Very good. Now it's time to work with data sources. I'm going to add new data sources to Grafana instance. In the previous section, we learned how to add a new data source through code instead of UI, and we did that for Grafana Loki. I'm going to do the same for Grafana Mimir and Mimir Alert Manager here. So we have a file called Grafana values.yum, and it contains the data sources of our Grafana instance. In the first section, we have Grafana Loki that we created earlier, and it's now available within our Grafana instance. But for now, for the current section, I'm going to add 3 new data sources: Mimir pods-tenant, Mimir nodes-tenant, and the last one is Mimir Alert Manager. Okay? First of all, let's start with Mimir pods-tenant and nodes-tenant. As you can see here, the type of these 2 data sources is Prometheus. The type is Prometheus here and Prometheus here as well. But why is the type is Prometheus? And why not Mimir, for example? If you probably know, Grafana Mimir has not a specific data source within Grafana. So whenever you want to connect and integrate Grafana with Grafana Mimir, you need to add a data source of type Prometheus, because Mimir has not a specific data source, okay? The type of a data source is Prometheus, but the information is about your Mimir instance. For example, this is the URL related to your Mimir instance, but the type is Prometheus because Mimir has not a specific data source within Grafana. Okay? The next important thing here is the URL, Mimir-Nginx. As I said earlier, one of the components that we deployed is Nginx, is a reverse proxy that is responsible to proxy requests to Mimir cluster. And here, for the URL of our Mimir, we type the URL of the service Nginx here. The service related to Nginx is Mimir-Nginx namespace is mimir.svc.cluster.local/Prometheus. This is the URL of Mimir. And the URL of alert manager here is this. For the alert manager, you don't need to include /Prometheus, and / is enough for alert manager. But both of them are using Mimir-nginx for the URL. Very good. The next important thing here is x-scope-orgid. If you look at these two different data sources, I mean Mimir pods-tenant and Mimir nodes-tenant, these two data sources look similar to each other. They are using the same type, same access, for example, orgid, the same URL, the same version. But the difference between these two data sources is the value of x-scope-orgid. The value of x-scope-orgid here is pods, and here is nodes. X-scope-orgid specifies the tenant ID. For example, the tenant ID of this data source is nodes, and the tenant ID of this data source here is pods. In the next section, I'm going to show you how multi-tenancy works within Grafana Mimir. But for now, I'm going to explain the scenario of this course for Grafana Mimir. Please pay attention here. It's so important. In the next section, I'm going to install Grafana agent. And this agent will be responsible to scrape metrics from different types of targets. For example, it will scrape metrics from my node, my Linux machine node, as well as scraping metrics from Kubernetes pods. So it's scraping metrics from different types of targets. Okay. I'm gonna say to Grafana agent that, hey, whenever you want to make a request to Grafana Mimir to write your metrics remotely to Mimir, please specify a header within your HTTP request. And this header includes a key as well as a value. The key is, for example, x-scope-orgid, and the value will be the name of the tenant. For example, I want to say that, hey, whenever you want to scrape metrics of my Linux machine nodes, please specify the tenant equals to nodes. And whenever you want to scrape metrics of my Kubernetes pods, please specify the tenants to pods. Okay? So, in this situation, whenever you specify a key value pair for x-scope-orgid, and whenever you define a tenant ID for the HTTP request of Grafana agent, the metrics of your nodes will be stored in nodes-tenant. And the metrics of your Kubernetes pods will be stored in pods-tenant. Because you are specifying the tenant ID within your HTTP requests. For example, HTTP requests of Grafana agent to Grafana Mimir. Okay? So you are isolating metrics from each other. You're isolating metrics of nodes from pods. Okay? This is the side of write operations. Write operations, I mean write from Grafana agent to Mimir and specifying a tenant ID. But what about read side? I mean, for example, I'm gonna perform my queries against these data sources within Grafana. This is the read operation. Okay. So I need to add two different data sources with the same URL, but with different tenant ID. The tenant ID of Mimir pods-tenant as a data source is pods, and the tenant ID of this data source here is nodes. So here, whenever you, for example, whenever you perform a query against Mimir-pods tenant data source, you will see only the metrics related to your Kubernetes pods. And whenever you perform queries against Mimir nodes-tenant data source, you just only see the metrics of your Linux machine nodes, for example. So by this way, you are isolating metrics from each other using multi-tenancy. This is the power of multi-tenancy within Grafana Mimir, which helps you a lot to isolate metrics from each other. I'm gonna do that in the next section, so please wait for the next section, okay? But for now, I'm gonna add these new data sources to Grafana. And also the last data source here is Mimir Alert Manager. The type is Alert Manager here as well, and editable is true. The default data source here is Loki, but I'm gonna change it. So I remove its default from here and add it to, for example, Mimir pods-tenant. It's default true. So in this situation, Mimir pods-tenant will be the default data source because I have multiple data sources. And here in this situation, Mimir pods-tenant will be the default tenant. So I type Helm upgrade Grafana -n Grafana Grafana/Grafana-f Grafana values.yaml. And the Grafana has been upgraded. So when I type kubectl get pod-n Grafana, the new instance has been deployed and the previous instance is going to be terminated. Okay, so this is the new instance of our Grafana, and now I'm going to connect to Grafana through UI. So I type kubectl get secret-n Grafana here and -o YAML. This is the password of my Grafana instance. Your echo and pipe it to base 64-d. Very good, I copied, but before that, we need to expose the service of Grafana. We can use the node port service or load balancer service or using an ingress, but in this course, I'm going to use kubectl port forward to expose our service temporarily. So I type sudo su, and here I type kubectl port forward svc /Grafana-n Grafana 8080 to 8 here. Very good. And I copy the password and let's go to the browser and I type localhost 8080 here. And we are connecting to Grafana instance. The username is admin by default. And the password that we grabbed earlier. Okay, I'm now connected to Grafana instance. So when I go to data sources, you can see that we have 4 data sources. These are 3 new data sources that we created: Mimir Alert Manager, nodes-tenant, and pods-tenant. And as we specified, Mimir pods-tenant is a default data source here. So let's click on Mimir Alert Manager. This is the URL that we specified earlier. And to verify it's working well, I click on Save and Test. And health check passed, it's working well. Do the same for Mimir nodes-tenant data source. The most important thing here that this HTTP header has been added here, x-scope-orgid, and its value here will be nodes, okay? So let's click on Save and Test. Very good. Do the same for pods. and very good. And this header has been added here as well. So these data sources have been added without any problem. And if you remember, we configured Alert Manager configuration within our Helm chart. So when I type Mimir values new.yaml, here inside Alert Manager fallback configuration, we specified the configuration of our Alert Manager here. So when I go to alert rules, contact points, I can choose an alert manager here. Alert manager can be Grafana or Mimir alert manager. I click on Mimir-alert manager here, and Slack is now available here. This is the contact point that we created through our Helm chart. Okay, so everything is good and everything is working well. So in this section, we explained the architecture of Grafana Mimir, and also I tried to set up Grafana Mimir and install Grafana Mimir within our Kubernetes environment. We added data sources to Grafana through codes instead of UI, and it looks so good. In the next section, I'm going to work with Grafana Mimir. I'm going to work with Grafana agent to script different types of metrics and write them remotely to Mimir, and working with multi-tenancy feature of Grafana Mimir, and let's see how it works. So thank you very much. I hope you like it, and see you soon.